morning everyone and welcome to the NPTEL course Advanced Distribution System Analysis and Operation. We are continuing with our module 11, that is the cyber physical layers in distribution systems. And in the last class we have seen that why we need communication system in the distribution network, what are their applications, and in each application what is the specification or standards normally followed. So, today we will see the communication process which is normally followed for this power networks, what are the mediums it is used, and a little bit an overview of the cyber threats. So, communication process in power networks is generally done by digital communication, that is the main communication technology that is followed. What it does? It changes any kind of analog signal to a digital signal, typically a 0 and 1, okay, over various communication channels. That means it is digitized, any analog signal is digitized and then it is sent to the receiver end. This offers high noise immunity, error detection, data encryption and supports integration with the modern IT system. Key components include transmitter, encoder, modulator, channel, demodulator, decoder and receiver. So, uses advanced digital modulation like phase shift keying and orthogonal frequency division multiplexing to improve the data rates and the robustness of the system. So, what are the sources, or you can say what is the architecture block diagram of this communication topology. So, we have this source encoder, you have channel encoder, you have digital modulator, then you have the channel to send the data. Then at the receiving end you have digital demodulator, channel decoder and the source decoder. So, first thing is the source which generates the data, that means your sensors, your smart meters, that is actually generating the message or the data. Then like your voltage or the current measurements, and then it is sent to the source encoder. So, the purpose of the source encoder is to digitize this or make it as a digital signal in the binary form, minimizing the redundancy. That means, whatever data you have, you will just convert it to a digital or a binary data 0101 combination data, depending upon that you are using the source encoder. So, that normally uses a analog to digital converter. Okay. Then you have channel encoder. What is the channel encoder? Added redundancy to the digital data to allow error detection and the correction. That means, you have a perfect data, you need to mask it with some redundant data, that if some hacker also attacks your system, it will not figure out that which is the actually needed information. So, that is done by the channel encoder. That means, your main data is masked. Then you have modulator. What it does? Converts the encoded digital signal into a form suitable for transmission by modulating it onto a carrier signal. Because if each and every medium like wireless or even in the wired, fiber optics or PLC, their transmitting data technology is not same. So, with that 0101 combination or your digitized data, you have to convert it to a proper communication medium feasible your data transmitting facility. So, that is done. What is that? That we will see. So, that is done in case of modulator. Then there is it is the phase shift keying or your OFDM used to modulate the signal for better transmission and performance. Then you have the channels, which is actually the medium which will send the data from the sending end to the receiving end. So, you can see this part is at your sender and this part is at your receiver. So, this is the sender, this is the receiver and that is connected via communication channel. So, that medium through which the signal travels from sender to the receiver, and it can be a power line communication, it can be optical fiber or any kind of wireless path. Then the data is reached through the communication medium to your receiving end. So, first thing which it will incur, that is the demodulator. That means, what you have done sequentially at the sending end, the same thing now you have to do in the reverse manner at the receiving end. That means, first you did your source encoding, then channel encoding, then digital modulation. At the receiving end, first you will do digital demodulation, then you will do channel decoding, and then you will do source decoding. Okay. So, what is demodulator? Extracts the original digital signal from the modulated carrier. So, that means in that channel you have some technology or by some means you have sent the data. Now you have to recover the digitized data or that 0101 combination from your system, right, or from your that can receive data. So, that is done at the demodulator. The same technology PSK or OFDM is used. Then you have channel decoder. So, that means whatever redundancy you add at the channel encoder to mask your actual information, now you have to throw them out or you have to select your actual information. So, that detects and corrects the errors. So, all the errors or redundant data you have added, so that you will figure it out and then just throw them out or filter them out. So, that is the parity check of the decoding algorithms to recover the clean data. Then at the last you have source decoder, which converts the error free digital back to the original form, that means the analog form or video form or audio form, whatever is there. So, you have sent an audio or video and analog data, converted it to a digital data, masked it, then changed it in the proper form which can be transmitted to the transmitter or the medium that you have used. Then again do the reverse process, you change it to the digital data and then take all the filter out all your masking or the error data, get the actual cleaned information and then change it again to the analog data. That is, you can say, the overview of the digital communication is normally followed in the power system. So, what are those communication mediums now? So, distribution system typically use a combination of wired and the wireless communication, not a single type of only used, chosen based on the infrastructure and the application needs. Wireless communication is often preferred in complex or hard to access area. That means where it is very difficult to stretch the wires or you send or install the wiring mediums. Let us say very hilly areas or very remote places. Okay. So, there normally we go for wireless communication, and wired communication is generally more stable and less prone, because it is very easy to hack or to, you can say, dope any wireless data. Okay. It is very easier for the hackers to enter to that medium, but for your channel medium or wired medium, that is difficult. So, normally when you need a reliable or you need a safety requirements of your data needs, so at that time normally we go for wired medium, which is less prone to interference, making it suitable for environments requiring high reliability. Selection depends upon factors like geography, technical needs, operational demands and costs, and no single solution suits all scenarios. Okay. That means it is not possible that in Delhi, if you have a communication medium, that same communication medium will work in the Ladakh as well. Okay. So, everywhere you have to see that what is the geography, what is the customers, what is the technical needs there. You are installing it for AMI or you are installing for substation automation or you are installing for protection purposes or you are installing for your automation purposes, what you are doing. So, depending upon that you have to choose wisely your communication medium. So, that can be wired or wireless. In the wired you have PLC, optical fiber, Ethernet, and in wireless you have Wi-Fi, Zigbee, cellular, WiMAX and satellite communication. So, first we will see the power line communication. So, power line communication uses the existing power transmission lines or the distribution lines to transmit high frequency data signals ranging from few kilohertz to tens of megahertz. So, in the power line, with the power signal, that is a 50 hertz or 60 hertz frequency, will send our data as well, in the communication data as well, with the range of few kilohertz and megahertz frequency level. So, PLC has a lower initial cost as it leverages the existing power line infrastructure. So, you need not to install more, like extra invest more cost to install your communication infrastructure. You are just using the power infrastructure which is actually there, which must be there for your power supply. The technology is mature, commercially used for decades and considered highly reliable. PLC is applicable across almost all parts of the power networks, from low voltage home appliances to the high voltage grid automation. So that is very cost effective actually. You are using the same thing for two purposes. So that is mainly widely adopted in all over the world, even for the HAN level to the WAN level. So PLC offers high throughput and low latency, making it suitable for smart grid communications, particularly in densely populated areas. So depending upon that, two kinds of PLC is there. One is called narrowband PLC, where the frequency is from 300 to 500 kilohertz and data rate is 10 to 500 kbps, and range is only till 3 kilometers. And that is also depending upon that you have low data rate and high data rate, which is 10 kbps and your 1 Mbps multi carrier, and 10 kbps single carrier if it is a low data rate. If it is a 1 Mbps multi carrier, then it is a high data rate. Then you have broadband PLC, which has 1.8 to 250 megahertz of frequency range, and your data rate is around 300 Mbps. So, how this communication process is done in case of PLC? First, you have a data generation, that means same like you have sensors, your smart meters which will collect the data of the grid status, power consumption and the temperature. So, this will act as a data source. So, you have data source here. So, this is the overall architecture of the PLC medium. So, this is your power line, this is your transmitter or receiver. If it is a two-way communication, so it is transmitter or receiver, it is another end transmitter or receiver. So, first we will do modulation, the same thing, the data is encoded onto a high frequency carrier signal, typically between a few kilohertz to the 250 megahertz. So, at the transmitter level, first you will do the modulation, that is the channel and as well as source modulation. Then signal injection, then you will inject that signal to the power line. How you are doing it? The modulated signal is injected into the power line through a coupling devices, that means this coupling capacitor. So, this ensures the communication signal is superimposed on the existing AC power signal without interference. That means, it is just an superimposing two signals with each other. You have your power signal of 50 hertz frequency, then you have your communication signal of few kilohertz or megahertz frequency, you just superimpose both of them and then send both of them. So, that is done by the coupling capacitor. So, the purpose of the coupling capacitor is a high pass filter. That means, whenever this will reach to the receiver level, it will only collect the high frequency one. That means, your kilohertz and megahertz level of signal, and it will reject or it will not allow the low frequency signal, that is the 50 or 60 hertz power signal, to flow through it. Okay? So, this will act as a high pass filter. Then line propagation, the signal travels through the electrical wiring infrastructure alongside the electrical power. So, with the power, this will be sent to the receiver. So, signal extraction and a demodulation. So, at the receiving end, another PLC modem extracts the data signal from the power line. So, you have that coupling capacitor in this side as well. Provide electrical isolation between the high voltage line and the sensitive communication infrastructure, because your communication infrastructure, communication signal power is very low compared to your actual power system power. Okay. Then you have this line traps. Okay. What is the line traps? Coupling capacitor, it is not allowing the low frequency to signal to flow through the communication infrastructure. Similarly, or conversely, your line trap, that is not allowing the high frequency signal to go to the other side of the power system. Okay. So, that will act as a low pass filter, that will only pass the signal which is having the frequency of 50 to 60 hertz in the range. Okay. So, the PLC modem decodes the extracted signal and then into digital data. So, you have whatever data you will get, then you have extract it and then you are good to use it. Data concentration, repeaters or data concentrators aggregate and forward the demodulated data to control centers for final processing and system. Then the next wired medium, that is your optical fiber. Optical fiber communication is a method of transmitting data using light signals through the strands of glass or plastic fibers. So, there you are using lights depending upon your 0101, you can make it like a on off on off. This is your off, this is your on. So, you just on off a light, and that light will be transmitted through the medium from sending end to the receiving end, and by decoding that lighting events you can see that what digital data you are receiving, okay, and that is done through a glass plastic fibers. Uses thin strands of glass or plastic fibers to carry light pulses representing data instead of electrical signals. We are not sending it as an electrical signal like we did it for the PLC. Here we are seeing it as a light signal. Okay. Offers very high bandwidth, low signal attenuation and immunity to electromagnetic interference, making it ideal for long distance and high speed communication. Okay. Used mostly in case of vans for substation automation, SCADA system, PMU communication and utility control centers due to its reliability and speed. Components: transmitter converts electrical data into light signals. Then you have optical fibers transmit light pulses over distances. Then you have receiver converts the received light signals back to the electrical signals. So, this is the overall structure of the optical fiber communication process, where first you have the data source, the original information is converted to into an electrical signal, that is the sensors, the same data source is same for everyone. Then you have transmitter circuit, that electrical signal is converted to a modulated light signal using a laser diode or LED. This is your transmitter circuit, and then you have that light source that will make, you can see 1010 is converted to on off, that is the light source on off. Then you have optical fiber cable, the light signal is transmitted through the fiber cord over long distances with minimal loss. Okay? That means the light will propagate through the communication medium. Then you have optional, if you need of amplifier, that means if it is a very long distance. So, at that time to keep the strength of the light, because obviously a medium, whenever you will send the light, it will absorb some of the energy of that light, that is there. Any medium that absorbs, not completely reflect your energy. Okay. There is nothing called ideal medium, that you will send an energy or signal and the medium will completely reflect it and it will send it to the receiver. It is never ever possible. So, every time it is reflecting, so with that even it will absorbing also some of the energy. Okay. That you know, light, when the light falls on a surface, that is your incidence one. So, some portion will be reflected and some portion will come absorbed within the medium. So, that is all the time it is possible, all the time it is happening. So, if it is a very long distance, it is happening that if you do not use an amplifier, so what will happen, that nothing will reach to the, or very weak signal will reach to the receiving end. So, that you do not want. Then you have an optical receiver, the incoming light signal is converted back into an electrical signal using a photo detector. Signal processing, the electrical signal is filtered, regenerated and decoded for clarity and accuracy. Then you have the output device and get your 1010 output data. Ethernet used in mostly in case of WANs between substations and control centers, and also in home home area networks. We have Ethernets in our home like for internet purposes. So, normally that is used. Offers high availability and reliability, because normally Ethernets are dedicated, that you do not share that Ethernet of your neighbor for the data processing or data transmitting. So, normally you have a dedicated Ethernet connection that will send the data from one end to another end, suitable for both long distance utility and short range home appliances. Then you have Wi-Fi, that is normally based on the standard IEEE 802.11 family standard, widely used for home wireless standard, enabling smart appliances and home energy management. Already integrated into many consumer electronics and well suited for hand application. The range of the Wi-Fi is very small, that is only one home, or let us say 2-3 homes. The only this, if you have a very strong router, then it is 2-3 homes. If it is a weak or medium standard routers, then it is only for one home. Then you have Zigbee, that is followed with the IEEE 802.15.4 standards. It is a low power short range mesh network with 10 to only 100 meter of range. So, it is a very short range, only a let us say single room you can cover. single room, or sometime you can go to like just a area, from a small area like a small room to a small area, not a very big utility area or distribution network you can cover. Data rate is also very low, that is 250 kbps, good for hand apps, automation and smart metering. So Zigbee well suited for using hand application, uses for remote monitoring, home automation, consumer electronics and smart meter reading. Okay, it is like the sending data, you can collect also inside the home, also you can collect the data with the help of Zigbee, or you can send that data to that aggregator level. That means you have your smart meter over here and you are sending that data to your router at the aggregator level, local aggregator level, like say 5 to 10 customers are connected together. So that level you can send it to the Zigbee. Then you have WiMAX, that is followed by IEEE 802.16 standard, that is a short range wireless medium with 70 Mbps data rate and 50 kilometer range. So little bit of wide data range you can cover, or wide range of customers you can cover with data WiMAX. WiMAX is scalable and can be set up as a networks on local or regional level networks. Then you have cellular communications, that is the existing infrastructure, that what we are talking by phone, your mobile phones, that also can be used for sending data, what we are normally using as a app. In the app as well, what we are monitoring, right? If you have smart devices or charging facility, let us say you have a Tesla car. So that car charging facilities or the status of the car charging, that you can see on the app. So that is normally done with the cellular setup. So that is the 5G or 4G setups, whatever you have, depending upon that you can use the cellular communication. Then it is the satellite communication, that is a very huge data or huge range of area you can cover using the satellite, which is at the space. So useful for rural areas with no cellular coverage or as a backup, that whenever everything fails, so at that time, because satellite communication is very costly communication. So at that time we use this for controlling mainly the PMUs, mainly the remote controlling units, those terminal units. Normally those huge data set of PMUs, that will, you cannot send with a very good, even with a very good wired or wireless communication. So at that case, generally this satellite communication is used to send that huge data from the PMU end to the control center end. So this is the advantage and limitation of different communication technology. You can see this is a wired one, you have a PLC, uses existing power lines for data transfer. Advantage is no new cabling, so it is a cost effective and cheap solution, but limitation is it has more noise and limited bandwidth. Then optical fiber, it is an high speed backbone communication, it is an high bandwidth and low latency system, but limitation is very expensive and complex installation. Similarly, Ethernet uses generally in the substation level, reliable, widely supported, but requires physical cabling. Then the comparison between different wireless communications, you have Wi-Fi, which is normally used for HAN and BAN or substations. You have advantage is easy to deploy, moderate data rate, but limitation is very prone to interference and limited range. That means only a single home. Okay. Zigbee, it is normally used for AMI, home automation and sensor network. It is a low powered mesh networking, low data rate and short range it is limitations. Okay. Then cellular, normally used for backhaul, remote monitoring, electric vehicles and DER monitoring. It is a wide coverage, reliable infrastructure, but it is a data costly and network congestion, because the same thing you are using for talking as well, for texting as well. So that gets a more priority than sending your power data. So sometimes congestion occurs and the data reaches to the receiving end in a delayed manner. Then you have WiMAX, that is only used for WAN and the backhaul, that is your bigger network level. High bandwidth and long range, deployment is very costly and interference, because any wireless communication is always exposed to your interference or cyber threats. Satellite, remote or inaccessible areas where it is like rural areas, very wide coverage, but high latency and very expensive. High latency because the data has to go to satellite, then from satellite it will come to your receiving end. So long distance it has to travel. Okay. So challenges in power communication, first you have a limited bandwidth, obviously no communication medium has infinite bandwidth level. it is always prone to interference and noise. You will get some latency because you will not get your data instantly. There is obviously some delay. So, how much is the delay depending upon your application, that you have to see. Security threats like the cyber threats, scalability and interoperability, because you are connecting multiple kinds of technologies together. So, which one is good, that you do not know. And even if they are interoperable, that means your wireless medium data is seamlessly converted to an wired data. So, that is possible or not. So, if you have to always install different kinds of equipment that will do this seamless transition. Reliability and availability, high deployment and maintenance costs, and the privacy. That means you are always sending a private data to the control center. Okay. Whether its privacy is restored or it is breached, depending upon that your communication medium is reliable or it is unreliable, that you can define. So, we will see the different kinds of cyber threats normally we experience in the power networks. First one is a malware or ransomware attacks, where malicious software can be infiltrated in the control system, steal data or lock critical system. Okay, that means normally you know that few softwares which are not good, that software, that link will come to the control center, and if any executive clicks on that link, bad software will be installed automatically to its system, and after that it will take data from that system, and that is the most of the cases, that is the reason of cyber attacks or blackouts, cyber attack related blackouts in the countries that we have seen in the Ukraine. Also there is a blackout. So, that is the reason of that. Then you have denial of service attack. It is overwhelming the communication networks or control system to disrupt or delay grid operations. That means you are that hackers actually they are purposefully congesting the communication system, that actual data is not able to reach to the control center on time. Then what is the control center will see, that data is not coming, so that device is not present. So, that is called denial of service. That means that service is not coming to the control center. Then data integrity attack, tampering with measurements or control data, example false data injection, and mislead the operators or automatic system, causing instability or blackouts. Unauthorized access and insider threats, compromised credentials or malicious insiders can access control systems and disrupt operation or leak sensitive data. Okay. Then you have advanced persistent threats, long term stealthy intrusions by well funded attackers aiming to gather intelligence or silently control systems. That means for a long time the attackers are taking data and then they are getting the service, like how your power system is operated. Every data they are collecting, that at the certain time they will attack and completely destroy your power system. Okay. Supply chain vulnerabilities, compromised software or hardware components introduced during manufacturing or updates can serve as backdoors. That means when you are purchasing a device, at that time only that bad software or that bad hardware is installed in it. So, whenever you will connect that device with your power system, obviously you are connecting a bad thing with your system. So, at that time the hacker can get, it need not to attack, it need not to infiltrate in your system is already having a bad thing. Okay. Then man in the middle attack, that is intercepting and possibly altering communication between devices, between substation and the control center. That means when one data, let us say this is your sending end and this is the data should be sent to the receiving end. Okay. This is your sending end, this is the receiving end, directly goes there. But sometime what happens, a attacker, a human being comes inside. So, it will take the data from the sending end, alters it and then send another data to the receiving end. So, that is called a man in the middle. Okay. So, at that time you are seeing that data is coming to me perfectly, but data is error data. So, then you will operate also erroneously, you will deviate from your actual optimal decisions. So, this is the comparison between different cyber threats, that malware ransom locks devices, steals data and halts operation. Example is ransomware shutting down utilities SCADA system. Denial of service causes downtime in monitoring and communication systems. It attacks the substation router, making it unresponsive. Data integrity attacks, wrong control actions, grid instability, false load data causing wrong energy dispatch. So, it sends that okay 5 kilowatt load is there, but it is not there. So, but you will schedule your generators like this and then you will dispatch. So, that will create the instability in the system between the load and the generation. Unauthorized access, system manipulation, data theft and sabotage, hacker accessing control interface through stolen credentials. Insider threats, intentional sabotage and data leak, operator disabling alarms or alerting set points. That means your operator, like your any human execute, that is a human, you can say human attack. A human intervention is there and then it is leaking the data from the system. Advanced persistent threats, covert manipulation, and then nation state actor silently monitoring grid behavior. Okay. Supply chain attacks, built-in backdoors or vulnerabilities, tainted firmware in smart meters. That means you are tampering the smart meters. Man in the middle, data manipulation, command alteration, altering control commands between substation and the control center is the scenario. So, now you can avoid the cyber threats. First, you can use the encryption. That means, whenever you will send a data, do not send the raw data, encrypt it, mask it. Okay? So, if you do this, encryption secures communication between devices and data centers, preventing unauthorized access and the data breaches. So, if it is a masked data, no one can identify what you are sending. Okay? If he does not have that proper algorithm how you have encrypted. So, if he does not have that, then you are good, you are safe. So, if an hackers also try to hack, so normally hackers they try to hack every day, every hour. So, every power system is experiencing hacking or cyber threats every day or every hour, but we are keeping that system safe by this encryption, because that algorithm is not known to them. So, they are getting some bad data from it. So, actual data is good and it is safely conveyed to the receiving end. So, for that normally the different standards used like advanced encryption standards and triple data encryption standards are commonly used in the power networks. Access control, that who can access that encrypted data by using the identification and the authorization, ensuring only trusted entities interact within the grid. Then you can use authentication and authorization, that means if something is coming or something is alarming or it is showing that one customer is going to add or one customer is requesting for power. So, first give an authorization signal, it is like a password, that whether that customer is a real customer or it is a cyber attacker. Okay. So, identify the verification, identify verification. Authentication confirms the legitimacy of the user's devices or application attempting access. Then permission management, authorization ensures authenticated entities have the appropriate rights to perform actions or access specific data. Then smart grid needs, smart grid require layered authentication. It is not only one authentication, you need device to device authentication, device to network authentication, then user to network authentication to maintain your system more reliable and secure from the cyber threats. So, with this I will end today's lecture and we will continue with the different aspects of the communication medium in the next lecture. Thank you.